This is an orthokeratology case where the patient's lenses have been um, changed a few times to accommodate for residual myopia, and the patient's got good vision now except for some halos at nighttime. So refractively, we're doing okay, but I think the small treatment zone we've got is interfering with the patient's nighttime vision. So halos is one of those things which I think is a little bit harder to get rid of in wave. Um, it's hard to make a lens that gives you a very wide treatment zone but still maintains centration. The post-Bohr maps that you have right now show really good centration of the lens, and there are kind of two strategies we can look at to get a larger treatment zone and hopefully maintain that same centration. So I've got the right lens up. Right now it's the most recent lens for the right eye. These are the same lenses in the two windows. And one thing we can do is just move the OZ and the IC control points back so that we've got more room in the center. The other thing we can do is add asphericity to the lens. And I feel like the asphericity helps a little bit more in terms of size of treatment zone, but sometimes it does distort the optics a little bit. And but I'll show both ways, and you can kind of decide which one makes the most sense to you. So right now we have an OZ at 6.3, I'm guessing 6.9. So if we were to move this back maybe a millimeter or so, and we also want to note that our power right now is 1.23, and what I kind of use as a gauge is where the tear layer crosses the 20 micron line. So where do you start to see fluorescein? Right now we're at just over 3 millimeters. So if we were to move this back 7.9, and we don't want any vertical movement of the control point, just horizontal. So the lift change in the top left corner should be 0, and all we're changing is position. And this is going to be 7.3. Again, no lift change. You'll notice that our power went down to minus 0.04, so we do have to increase our power and get back to our 123 that we had originally. And I'm going to spin around and tidy up the individual meridians so that they're a little bit more uniform. Okay, so that's pretty close to the 1.23 that we started with. And if we see where the line crosses, we're at, oh, maybe 3.1 millimeters. So we've added a little bit, and this is, I don't find this to be a one-to-one, meaning we're going to get 0.2 millimeters greater in diameter of a treatment zone. But I feel like it's just not a huge difference, and we do have a lot less lens out here now to maintain centration on the cornea. But this, I think, will give you a slightly larger treatment zone, and it may even be enough to get rid of the patient's symptoms. In this window, I'll show you how we can add asphericity to the lens. I usually start with 0.2. It's a little bit arbitrary, but it seems to work well. And in this case, we don't want to go by the power, because when we add asphericity to the lens, it changes the front surface power of the lens. We want to go by topo demand. So our original topo demand of 4.88, the very original was 4.83, which is pretty close, is what we want to match. So in this case, we can actually decrease our demand. Oops, too much. Okay, and 4.83 was what was in the original lens. So we're pretty close there. Again, I'm going to go to 25% and tidy up the meridians. We're at minus 0.82, and that's pretty different. That's close. Wrong way. Okay, 0.82, but our topo demand is off again by a little bit. So we're going to have to bump that up a little bit. Okay, now our power is 0.69, and it's still pretty close all the way around. Sometimes it's a little bit of back and forth to get everything evened out. Okay, so you can see the new lens, it bears a lot more centrally, and it does kind of push this tear graph out a little bit. We're out to 3.45. So still, it's not a huge difference from where we started, which was right around 3. But this seems to give us maybe a little bit more than we would get just by increasing the size of the OZ and the IC. In the case submission, there is also a comment about turning off the blending on the lens, and I think that may help a little bit too. I've seen where the sharper transition in the reverse curve of the lens does give a little bit more room. So, but I have not seen that work if you add asphericity to the lens. So, turning off the blending so that we get sharp curves. Even though it doesn't show that much here, I have seen a slightly, usually we'll get a more distinct post-wear ring on the cornea, and the central treatment zone will be a little bit wider too. So either move the OZ and IC back and turn off the blending, or leave it on and then consider doing asphericity, adding asphericity to the lens. If I have a lot of concern that the patient's lens will decenter, then I'd probably choose this route. If adding the asphericity, if the lens has always maintained a good centration, then this route, I think, is optically a little bit more straightforward in the center part of the lens. When you introduce aspheric optics into the center part of the lens, it sometimes messes with the patient's vision. So 2 ways to go about it. Hope one of them does help out, and thanks for watching.